Okay, chapter 27, this is it, last one, day one, the only day we've got. This type of data chapter works on inference for regression, inference for our least squares regression line, inference around this line. Now, when we think of a regression line, and you don't have to draw this, we think of an XY axis, we think of data, we think of a line that passes through the data. This test is all about looking for association, like the last chapter, but the last chapter was all about categorical data. This is about quantitative data, all right? So, again, just like last chapter, my initial hypothesis is all around the fact that there's no association. But in a regression problem with a scatter plot, no association would mean that I have a regression line that basically has no slope to it. There is no pattern, there's no association. Whether it's positive or negative, there's no association. So if you remember the equation y equals a plus bx, b being the slope, the parameter is this Greek letter beta with a little tail down the bottom. Our null hypothesis is that the slope is 0. Okay? This says 0 slope. Not no slope, but 0 slope, horizontal. Alright? So, null hypothesis, no association, just like last chapter, but quantitative data. Alternative, it might have a positive slope, it might have a negative slope, alright? Or, I'm not sure which way it's going to go, positive or negative. I'm just curious if there is an association. I don't know if it's positive or negative. I just try to figure out if there is one. Here I'm thinking that there's a positive association. Here I'm thinking somehow there's a negative association. Here I'm not sure if there's one. I just would like to figure it out. So you pick an alternative just like before. But the parameter here is beta with a little tail down the bottom. Okay? So, since we're talking about linear regression, then our conditions are around linear regression. And so the first condition that we have is that the data is fairly linear. All right? You have to check a residual plot. All right? You have to check your residual plot. Make sure that the data is fairly linear. And that there's no trend in the residual plot, so no fanning. Again, check your residual plot. If it works out, we say it's okay to do a linear regression t-test. Since we're dealing with quantitative data, we're back to a t, all right? And so this is called a linear regression t-test. So our t-value here is all about taking the slope, dividing it by the standard error for the slope. And this information you'll get right off your calculator. The degrees of freedom here is n minus 2 because we have two sets of data. This one can vary by one less, this one can vary by one less, and they are paired up, okay, like height and arm span. So n minus 2 is your degree of freedom on this one. So this t will have a degree of freedom number as a subscript, all right? Here's the good news. Basically, you will not do this one by hand. You're either going to use your calculator, or sometimes they give you a computer output and you just have to be able to read it. And so one task we're going to look at is how to read a computer output. So in your books on page 657, you'll see this computer output. All right? Now, the computer output has columns. One's called variable, coefficient, standard error of the coefficient, t-ratio, and probability or p-value. They'll interchange those names. So here's an example that's given in your book. All right? The variable, the y-intercept, and the x variable. All right? Now, I can write an equation from the computer output. We already did this before. This is the A, this is the B. A, B. because A is the coefficient of the y-intercept. B is the coefficient of the x variable. The coefficient is the number. So from this information, I can write a y-hat equation. We have done this earlier in the year. The rest of this stuff, I told you was going to come later. Well, today is the day. What else does this tell us? Well, the standard error of the slope is given to us right here. Standard error beta, 18.77. All right? So when I want to try to create a t value, I take beta divided by SE beta, and I can get my t value. I don't really need to do that by hand because, lo and behold, it gives me a t value for the slope, 3.27. P value would come from the chart in the back of the book, but the computer output gives it to us. Now, the thing that you have to remember with a computer output, though, is this is a two-sided p-value. Two-sided. The sum of this and this is 0.0018. You have to remember it's a two-sided p-value. So that would only be used for the two-sided alternative. Okay? If you have a one-sided alternative, you would take that computer output value and chop it in half. So for a one-sided alternative, cut this value in half if you're reading computer output. If you're using your calculator, the calculator will do it for you. Don't have to worry about it. If you're using your TI, no worries. If you're reading computer output, just pay attention that the p-value given is for a two-sided alternative, and if you're a one-sided, you'll chop that in half. Now, sometimes we know that there's an association and we don't really need to do a test. For example, I'm pretty sure there's an association between my height and my arm span. All right? Duh, there is one. I don't need to do a test, but I'm curious as to how much it is. What is that association? What is this slope? And if that's the case, then I can do a confidence interval for slope. So I know there's slope. I'm just curious as to how much of a slope it is. So again, if we think back to general confidence interval setup, okay, in general, it's what we're trying to estimate, plus or minus critical value times standard error. So for this problem, we're trying to estimate the slope, okay, plus or minus t star, now with n minus 2 degrees of freedom, and then standard error of beta. All right, conditions, same. You still need to make sure that the residual plot looks good, both that there's a scatter and no fanning, all right? If we meet those conditions, it's okay to do a linear regression t-interval. Basically, you're going to put the data in, run it on your calculator, fill in these blanks. This will come from the back of the book still, page 880 out of the back of the book. Let's take a look at an example. Is there an association between height and arm span? So is there an association? So my null, no association. My alternative, I wonder if there's an association. Okay? So what I did is I grabbed 10 of our data points from the height and arm span data that we had. All right? I put them into my calculator. I made a residual plot, and if you notice, pretty much a random scatter. All right? This is the height. This is the resid. The residual plot has a random scatter and no fanning. So therefore, it is okay to do a linear regression t-test. So I run this thing on my calculator. Stat test, you'll see one called linear regression t-test. This is the output that it gives to me, all right? It tells me what t is, 1.83 if I round it. Again, I'm 8 degrees of freedom because I did 10 data points. My p-value it gives to me 0.10. So I write my conclusion with a p-value of 0.10, which is greater than the rule of thumb, alpha 0.05. And I chopped it off, but we what? We failed to reject the null hypothesis. There is not enough evidence that there is an association between height and arm span. Okay? I could create a confidence interval for the slope. I wonder what the slope of that line is. So I take beta plus or minus t star standard error beta. Now, if I solve for standard error beta, I can find it if I know beta and t, which I already have the information for. Very rare that you have to do this, okay? But again, you could still get the information, all right? Basically, I'm going to run it right on my calculator, and I'm going to get the answer. Usually, you'll see these in multiple choice. So here's my answer, and so I'm 95% confident that the slope of the line representing height versus arm span is anywhere from negative 0.10 to positive 0.93. And if you notice, zero's in my interval. And since zero's in my interval, it suggests no association. Just the way that the data that I used came out. Okay? But that's it. This is all about an association, but with quantitative data. Right. And that's it.